steroid isolation was carried out by maceration method by extracting Eucheuma cottoni red algae powder with methanol in a ratio of 1:5 for 24 hours using a shaker at 120 revolutions per minute. After maceration, the filtrate was filtered with a Buchner funnel. The result is that methanol turns green, which indicates that the steroid extract has dissolved in methanol. Furthermore, the filtrate is collected in a round bottom flask and a rotary evaporator is carried out at a temperature of 35 degrees Celsius to concentrate the results of maceration. A rotary evaporator is carried out so that the methanol solvent can evaporate quickly below its boiling point. From 20 grams of sample extracted in 100 milliliters methanol, the yield was 10.86% with 2.1731 grams. According to Senyawa, 2015, a study conducted by concentrated extract results obtained a yield of 8.54%. This difference is due to the age of the red alga Eucheuma cottoni used differently. Hydrolysis is done by adding 4 milliliters of 2NaCl to 2 grams of concentrated extract and stirring for 1 hour at room temperature. The goal is to break the glycoside bonds connecting the glycans and the glycones. Then to stop the hydrolysis reaction, add NaCO3 until neutral. This addition during the experiment required 130 drops of NaCO3 to neutral. Next, liquid extraction is continued, namely partition with 10 milliliters of anhexin and 10 milliliters of ethyl acetate 3 times each. Multi-level partition is performed to maximize the results of the separation. Partition is useful for separating nonpolar steroid compounds from other polar compounds. From the partition, a fraction of 0.346 gram was produced with a yield of 17.3%. Phytochemical test was carried out with 1 mg extract of partition results with Lieberman-Burchard reagent. This reagent is made of half a milliliter of acetic acid anhydride and 1 to 2 milliliters of concentrated H2SO4. The addition of H2SO4 is done very carefully because it is corrosive and volatile at high concentrations. Based on experiments that have been carried out, positive results on steroids are indicated by the appearance of green on the test tube and positive on tridipenoids, which is indicated by the presence of a brick red ring. The Lieberman-Burchard test is indeed often side by side with a tridipenoid. The results which have been extracted liquid with a multi-level partition are then separated by wet column chromatography using a mixture of anhexane and ethyl acetate eluents in a ratio of 4.5:0.5. The flow rate used is 1 milliliter, minute and eluquites are accommodated every 2 milliliters. Eluent storage of 2 milliliters to minimize remixing of compounds that have been separated from the column. The elution process is stopped after the adsorbent color fades. The waning color of the adsorbent shows the compound which is absorbed in the silica that has been eluted by the mobile phase. The total volume of the mobile phase used was 300 milliliters and 127 vials were obtained. Based on the results of the characterization using FTIR produces a typical absorption of steroids at 1650.585 cm-1 with C equals C and 1260 cm-1 groups indicating the secondary alcohol group. From other fractions, we get both absorption at the same wave number and other uptake.
Synthesis of basic Schifft-methoxy-4 P-Toluidin-methyl-phenol compounds are carried out by reacting vanillin as a provider of aldehyde groups with P-Toluidin as a provider of primary amine groups. synthesis is carried out using the grinding method. The use of the grinding method can accelerate the reaction, so the synthesis this time does not use solvents or acid catalysts to produce a more maximum reaction, so that the yield obtained is expected to be higher. In the grinding process, the process of converting mechanical energy into heat energy is the driving force of molecular activation. After being crushed, the synthesized product is roasted to remove its water content. The Schifft base formation reaction involves an addition-elimination reaction. The N atom will act as a nucleophile because in the compound P-Toluidin electron dispersion will be docked at the N atom, while C-carbonyl in the vanillin compound acts as an electrophile because the electron cloud on C-carbonyl will be attracted to the O atom. The reaction between the vanillin molecule and the P-Toluidin molecule involves the electron pair transfer process, in which vanillin acts as the recipient of an electron pair, Lewis acid, and P-anisidin acts as a donor of the electron pair, Lewis base. Then the product is washed with distilled water and produces a yellow filtrate. Vanillin and P-Toluidin are colorless when dissolved in distilled water. However, the leaching filtrate of the synthesized product is yellowish in color, indicating that there are new compounds dissolved in the washing process. Then it is dried using a desiccator to bind the remaining water molecules to the product so that a constant product weight is obtained. Then do a physical analysis and calculated the mass obtained on the product. The synthesized product has a yellow solid form with a yield of 93.76%, so it can be assumed with the yield that the synthesis product has been formed. The melting point test results of the synthesized compound showed the product melting point of 118 degrees Celsius. The melting point of the product tends to be higher when compared to the melting point of vanillin, 80 C, and toluidine, 44 C. The difference in the melting point of the reactants and the resulting compound strengthens the indication that a new compound has formed. The synthesized compound is soluble in sodium hydroxide, which is characterized by a change in the color of the solution to yellow. The solubility test of the synthesized compound is based on the principle of the Bronsted-Lowry acid-base reaction, where the reaction between acid and base will produce a water-soluble salt. In the product compound being tested, it is suspected that there is a phenolic group in its structure which is characterized by an acid capable of releasing hydrogen ions. Reaction with a strong base of sodium hydroxide will cause the H+ ion in the Schifft base compound to be replaced by the Na+ ion and form a sodium salt that dissolves easily in water. So the addition of 2 molar sodium hydroxide bases will cause solids to dissolve completely in water. FTIR characterization was carried out to determine the functional groups contained in the synthesis product. FTIR spectra of the synthesis product were obtained. The functional groups were identified to determine the presence of the target compound in the synthesis product. FTIR analysis of the synthesis product was carried out using the KBR pellet method. Absorption band readings are carried out at wave numbers 4400 cm1, then the results of the peaks that appear in the spectra are compared with existing literature. Based on the FTIR spectra of the synthesized product obtained, the absorption of the stretch OH stretch group read with a weak and widening intensity in the region of 3468 cm1, and is supported by the uptake of the CO stretch phenol group in the strong and sharp 1214 cm1 region. Absorption of CSP2 aromatic stretch has a wave number of 3,093,825 cm1 with weak absorption supported by the presence of weak overtone aromatic in the region of 2200-1800 cm1 and strong absorption of C equals aromatic functional groups at 1600 cm1. The COC stretch group with strong and sharp absorption characteristics is read at wave number 1031 cm1. Then the appearance of a typical absorption of the imine group C equals N at the wave number is 1590 cm1. based on the results of the FTIR spectra analysis obtained. It was suspected that the target compound had formed in the synthesis product. Characterization of product compounds using GCMS was carried out to strengthen the suspicion that the target compound had been formed. This analysis combines the gas chromatography method, which aims to separate the compounds contained in the product and mass spectra that provides the structure of the compound based on MC values. In addition, characterization using GCMS instrumentation can determine the number of compounds contained in the sample based on the chromatogram produced and to determine the mass of the compound formed in. Predicted structure based on the mass spectra that appears. Based on research conducted by Hassana, 2017 shows the results of the analysis using GCMS that the product synthesis has a purity of up to 93.7679%. The target has a molecular ion with Mz241, which indicates the weight of the Schifft-based compound. This shows that there are other components in the product synthesis in the form of reactants, residues and small amounts.